Hi everyone. This demo is part of my Openstack Juno series. So here we'll walk through the Neutron configuration for setting up two nodes in a DevStack cluster, and we will instantiate VMs across the cluster and be able to ping each other. To start with, first, so this is the controller host that I have already set up, and I'm in the Horizon interface. So here we see one of the hypervisors that is present, which is basically the local host. And if we look at the local.conf file, which controls the the services that is started. So pretty much I've disabled the NOVA networking and I have enabled Neutron networking, and I've used the ML2 plugin with Open vSwitch as the agent, and I've used the tunneling type as VXLAN. Um, Okay, the first step is going to be able to create a compute host. I've already created the compute host, and so if you look at the settings under the compute host, the main things that is there in significance is, okay, the memory. I've put it at 6 GB, but you can have it lesser for a compute host. The memory requirement is a lot lesser than the controller host because very less services are going to be running. From the networking perspective, I have the bridge adapter, which allows the external connectivity, and then I have the host only adapter. um, this should be yeah. So with this setting, let's start the compute host. Okay, so my compute host is up now. So I also have an associated blog that I have written where I have walked through the steps here. You can just follow both of them together. So here I have a local.conf.compute in the GitHub. So I have copied that here. So let's look at what is in the local.conf file. So this is the compute local.conf. So number of services is going to be less. The first part is the logging, which is pretty much default. Then this part contains the credentials. So here is the host IP, and so here this is one thing that we need to change based on what we have set up. So let's look at the IP of the compute host, which is the host only IP. So this is the 8.1 interface, which has the 104 address. So here let's change the host IP here, and we also need to find the IP address of the controller host. So let's get that here. So the ETH1 interface in the controller host is 103. So let's update the compute host, the service host here, to 103. So everything else we can give it as default. So we have disabled all the services and enabled the bare minimal service that is necessary for this host to work as a compute host. And some of them are Neutron and some of the quantum services. And in terms of the plugin, we have the ML2 plugin with the Open vSwitch agent, and the tenant network type is VXLAN, which is going to be the tunneling protocol between the controller host and the compute host. We need to make sure that the tunneling tenant network type is the same on both the controller and a compute host, otherwise it's not going to work. Okay, so once we have changed the local.conf file, the next step is to do the stacking on the compute host. So we've already done the stacking on the controller host and it's already running. So we just do the stacking here. Okay, so now the stacking is completed on the compute host. It's going to be much faster than on the controller host. And so this is the host IP address. So now we'll go to the controller host and make sure that the controller host is able to see this particular cluster. So we go to the hypervisors, we should see two of them. Yeah, we do see that. So basically this is the first one is the controller host, and the second one is the compute host. And there are a couple of other things that I kind of wanted to show here. So I wanted to see that the tunnel is created between the controller and computer host. So for that we can see the OVS configuration. Okay, so here we have the bridge tunnel interface, which has the tunnel between the 103 and 104 IP address. 104 is the compute host, and so we're going to see the same in the compute host as well. So yeah, between 104, which is the compute host, to the controller host here. So we're back in the controller host. So here let's look at the network topology to start with. So currently there is no hosts that are created. So first what we'll do is go to the compute instances, and let's try to create 4 VMs. And what we should be able to see is these VMs should be distributed across the 2-node cluster that we have set up. So let's create 4 VMs and use the same Cirrus image, and the key pair and the security groups is fine. Networks, private network. So let's launch it. Okay, now that the 4 instances are created, so let's go to the admin instances tab. So here we see that 3 of the instances got created in the VirtualBox 1, which is the compute host, and one of them got created in the host 1, which is the controller host. And let's see, go to the project tab, make sure that the instances are running. Okay, so here we see all the 4 instances running. So let's go to the network tab and let's look at the network topology view. Okay, so here we see all the 4 instances. Actually, from this particular view, we don't even know that which VM got spawned in which host. They're all part of the private network. As long as the internal network connectivity goes, VXLAN tunnel is used to establish the connectivity across the hosts. To demonstrate the connectivity, what we'll do is do a ping between 2 hosts or 2 VMs that are across the cluster. So let's ping between this VM to any of the other VMs. So for that, first let's SSH. So let's log into the 10.0.0.15. So here, okay, so we have logged in here. So let's try to ping any of the 10, 16, 17, and 18. All the 3 VMs are able to ping each other. To see the VXLAN encapsulated packets going between the controller and the compute host, I started the Wireshark on the controller host. So here Wireshark does not natively capture the VXLAN packets, so there is some kind of a problem with the filtering. So basically what I have done is I have in the capture interfaces I have selected ETH1, and I have basically use the filter as a frame length greater than 900 so that I can easily filter the packets. Okay, let me restart this and let me do a ping here with 1000 byte packets, and here these are the VXLAN packets that is going back and forth. So if you look here, so this is the encapsulated packet with the source IP as 103 and 104, and this is the internal header basically, which contains uh, the uh, the the original VM packet. I just wanted to show that VXLAN encapsulation is being used between the two hosts. Um, yeah, thanks for watching.